right, so adding and subtracting was yesterday. Today is multiplying. And let's start out with example 1. As easy as it gets here, I want you to multiply a 2x cubed, which is a monomial, right? And I want you to multiply that by this x cubed plus the 3x squared minus 2x plus 5. And that's a polynomial, right? Because it has 4 or more terms. No special name for that. Now, you just did a whole lesson yesterday where I told you not to add the exponents, right? Because you were adding. And when you combine like terms, they just stay like terms. Today, however, what are you doing? We're back to multiplying. So what do you do when you multiply? Add the exponents. So I want to multiply this 2x cubed times every single term in that parentheses, okay? So a 2x cubed times a 1x cubed is a 2x to the, you got it, to the 6th. Then 2 times 3 is 6, and 3 plus 2 is 5. This is chapter 8 exponent rules, isn't it? Okay? 2 times negative 2 is negative 4, and 3 plus 1, don't forget about that plus 1. 2x cubed times 5 is 10x cubed. That's it. Okay? So when you distribute, which means you multiply, that's when you add the exponents. Okay? So today you're going to do both adding them and not adding them. You'll see. Got it? So that was a monomial times a polynomial. Let's do a binomial times a binomial. Did I spell that right? Okay? I'm going to show you 2 ways to do it. You could use a table to multiply a binomial times a binomial, because at first you're looking at x minus 4 and 3x plus 2 and saying to yourself, well, how do I do that? What do I distribute? So, option 1, and then I'm going to let you choose whichever option you want. Okay, so you're going to make a 4 table, 4 square like that, and you're going to put one of the binomials on one side of the table, each getting its own box, and the other binomial on the other side, okay? And you can choose to put whichever one. Multiplication is commutative, so you could have put it the other way. And then it's kind of like how a multiplication table works, doesn't it? You take these 2 and you follow them, and these 2 and you follow them, and you put the products in there. So the product of 3x and x is 3x squared. The product of 3x and negative 4 is negative 12x. You'll see why in a minute. I put it in red. 2 times x is a positive 2x. And then a positive 2 times a negative 4 is a negative 8. Okay, so why did you see me put those in red? Because they are like terms. And what do we do with like terms? Combine them. So let's put our answer in standard form, which is 3x squared. These 2 give me a negative 10x minus 8. That is multiplying 2 binomials using a table. Okay? Let's talk about multiplying 2 binomials using a method called the FOIL method. I think I did this with you last year, but you may or may not remember, so let's do this. Okay? I'm going to use the same problem so you see that we get the same answer, okay? Now, the FOIL method says this, and I'm not going to tell you what they stand for. You're going to tell me, okay? Basically, let's look at it like this. If that negative 4 wasn't there, man, this would be pretty easy, because all I would do is distribute that x, right? And boy, this would be pretty easy if that x wasn't there, because all I would do is distribute that negative 4, right? So you do both, okay? So let's distribute the x to the 3x and the x to the 2. And after that's done, let's distribute the negative 4 to the 3x and the negative 4 to the 2. So let's do that. So let's say x times 3x is 3x squared, right? Which is right here. X times 2 is 2x, which is right here. Now let's distribute and ignore the x. Some people need to cover it up. That's totally okay. Distribute the negative 4 times the 3x, which is your negative 12x. And then there's your negative 4 times your positive 2, which is your negative 8. Now you look to see where your like terms are. This one has an x squared with no other x squareds. This is a constant with no other constants. These are the only two that have like terms. So your final answer will be 3x squared minus 10x minus 8, just like it was in the other method. So now, what does FOIL stand for? F-O-I-L.
First, outer, inner.
Yeah, okay. So let's look at this. When we did the x times the 3x, do you agree that both of those are in the first spot in the parentheses? Okay, so we're going to say that first thing we're going to do is multiply the two first numbers. Then we did the x times the 2. And if these two are both on the inside of the parentheses there, these two are on the outside. So you'll see them saying outer, the two outer numbers. Then we did the negative 4 times the 3, and those are both the inner numbers or the inside numbers. Which then makes, if these two are the first, then the 4 and the 2 are the last. So, FOIL is an actual mathematical term defined in algebra books as first, outside, inside, last, or outer, inner, last. Some people go by trying to memorize that. I think it's way easier to just look at it as cover up the negative 4. Distribute the x, distribute the negative 4, and by default, you're doing FOIL. Okay? So you can look at it as basically just distributing both. FOIL only works when you are multiplying two binomials. If I would have tried to use FOIL up here, is there a first, an outside, an inside, a last? No. So FOIL only works when you're multiplying two binomials. Okay? Easy enough? All right. So let's multiply a binomial times a trinomial next. And basically, once you learn this first process, you can apply it to really anything. So let's take 2x squared plus 5x minus 1, that trinomial, and I want to multiply it by 4x minus 3. I want to point something out real quick, too, as you're writing that. What if I were to take these parentheses, move them a little bit apart, and put a plus in the middle? Then I'm not multiplying them anymore, right? I would be adding them, and that would be 9, 1 that we did yesterday. So let's distribute. Let's do the 2x squared times the 4x. That's going to give me what? 2 plus 1, 3. Then the 2x squared times the negative 3, and that gives you your negative 6x squared. Done with the negative, or with the 2x squared. Now let's distribute the 5x. And that's going to give me 5x times 4x is 20x squared. And 5x times negative 3. Okay. Next, let's distribute the negative 1. And negative 1 times 4x is negative 4x. And negative 1 times negative 3 is positive 3. Okay. Now I look to see if I have any like terms. These two are squareds. These two are x's. The rest just gets brought down. So your final answer is going to be 8x cubed. Combine your like terms, positive, negative, obviously. Same signs, add and keep. And then your constant. Pretty easy? Okay, so you're basically distributing using your exponent rules. Okay, let's give you an example of what you're going to see next year if you go to geometry. Okay, stuff like this. With geometry concepts, the algebra is going to be built right in. All right? So let's find the area. We know the area is length times width, right? It's probably the most commonly used, easily remembered formula. So if I were to say I have a triangle that's kind of separated in, or rectangle, separated into two shapes, and the length of this side is x, and the length of this is 6, and then this is 2x. I know people always say to me, well, which one's the length and the width? I get so confused. And, technically it doesn't matter because it's commutative, right? Multiplication. So as long as you multiply them, you'll get the right answer. To me, length is how long something is. So I picture like a train, okay? So to me, this is how long this is. So I'm going to call, just for the heck of it, this the length, and then this is going to be the width to me, okay? It's how wide it is. So everybody gets confused. They want to call the side length of this 6x. Well, what if I were to say this length is 5 and this is 10? What's the length of this side? 15, right? Not 50. So if you tell me that the side length of this side is 6x, you don't multiply these two, do you? So what is the length really? X plus 6. And I want to take that x plus 6 and multiply it by the, I almost put a W, by the width, which is 2x. So the hard part with these problems is setting them up. Once you get them set up, you should be good to go. The area of that shape with a length and a width of the given here is that, okay? Easy enough. I got one more to show you. This one's a little more involved. You've seen these problems before. And they ask for the area of the shaded region. Well, if this cube is an 8 by 8 and this cube is a 3 by 3, let's do it without polynomials first. What process would you use to find the area of the shaded region?
First, you square 8.
Yep. So without getting too detailed, I would just find the area of the whole cube, and then, yep. And then the next one, and then do what?
Subtract.
Yes. So you're going to subtract the area. So the shaded area can be found from the area of the large minus the area of the small, because you basically are just taking out that because it's not shaded, and that's what will give you the area of the shaded region, okay? So let's do that. What is the area of the large? It's a square, so it's 8 by 8. The area of the small square inside is? And then when you subtract them, you get, yep. Okay, we put a unit on there, call it inches, and this is inches. That would have to be inches too. Boy, that would make it a fun problem if this was inches, but this was centimeters, right? You're like, no, it probably wouldn't be that fun. Okay, so let's take this theory and let's do it with polynomials now. In other words, my big square is going to have side lengths of x plus 1. And this time there's a rectangle in it. And it's got a width of 5 and a length of x minus 7. And this is the shaded area. So let's talk about, what did we say? Area of the large shape minus the area of the smaller shape, and that will give me the area of the shaded, right? So let's find the area of the large. You can find the area of the large however you want, but basically what you have to do is multiply somehow your x plus 1 times your x plus 1. If you want to use a table, you go for it. If you want a FOIL, totally fine with me too. So this was your x and your plus 1, and this is an x and a plus 1. That's going to give you x squared, an x and an x here, and a 1. Or if you FOIL it, you're going to get x squared plus x plus another x plus 1, right? And combine that. When you FOIL, the easy thing to know is that your two middle just get combined. So that's going to be x squared plus 1x plus 1x is 2x plus 1. Now we find the area of the smaller, which is a little easier. No foiling necessary, because you're just distributing a 5. And that's giving you 5x minus 7. Now, technically, this is why it's a little tricky to do it this way. What I would do from here is take it and do the x squared plus 2x plus 1 and subtract your 5x minus 7, because what do you have to remember to do?
I have a question.
Go ahead.
What did you multiply the 7 by?
Yes, sorry, I'm talking and thank you. Okay, so as I'm doing this and it's set up this way, I may look, oh, just do this, but this is a minus, which really means what? That would be a minus and this would be a plus. So sometimes the vertical way can be tricky. If you set it up this way, then you'll know that this is a negative 5x and a positive 35. And now combine. X squared, no other x squareds. A 5x is negative and your 2x is positive, so this is minus 3x. And your positive 1 and your positive 5 is positive 36. And that is the area of the shaded region with those dimensions. Got it? Easy enough?